Hey guys, my name is Ashley Donaldson, and this is my final project presentation on mesh mold. So this is an introduction to mesh mold technology and construction and its applications. So the first thing I want to kind of do is just give us a little bit of a refresher from about mesh mold technology from what we learned in this course. So this is just going to be some things that were taken from the slides. So mesh mold is a method for robotic construction or prefabrication of structures and substructures. That's straight from the lecture. The uses, so robotic rebar reinforcement fabrication. Number two would be reinforcement cage is also used as formwork. So it kind of combines the two technologies. And it also enables construction of non-standard geometries. So I just kind of wanted to give you all a quick glance at the actual product, like what it looks like. So this right here would be your mesh mold technology. So as you see, you have like whatever mesh and whatever you make it out of, which it can either be steel or polymer based. And they're filling it in with the concrete here. So that's how it ends up looking with the contour curved structure. So what is mesh mold technology? So I took this definition from the Gramazio-Kohler Research Group, which is part of the original research group that was put together to actually create the mesh mold technology. So it is the innovative patented technology that combines formwork and structural reinforcement into one robotically fabricated construction system. So first, in order to fully understand mesh mold technology, we really have to understand the problem that the technology aims to solve first. So what's the problem? The problem would be that conventional construction methods do not allow for the efficient fabrication of non-standard geometries out of concrete. So now we take a look at mesh mold technology as a solution. So mesh mold technology actually combines formwork and reinforcement into one robotically fabricated construction process. So this is a look at mesh mold technology research project in Zurich, Switzerland, which is really the first time that someone had actually done research on the mesh mold technology itself. So mesh mold prefabrication is a project beginning in 2015 and was spearheaded in conjunction by the following organizations. So like I said, it began in Switzerland, University of Zurich. And then the Gramazio-Kohler Research Group was a huge part of it. And those are some departments that were also involved: Institute of Technology and Architecture and Structural Engineering. And then the last two, SICA AG and Peri AG, those are the organizations that created the admixtures for this technology. So the mesh mold technology research project was actually based on the original research objective to develop a robotic extrusion process for polymer mesh. So they had kind of been working on that all the way back to 2012, but they didn't fully integrate the polymer mesh until 2015. So mesh mold technology project objectives, essentially just like what are the goals that the technology would aim to complete. So complex geometries manufactured at no extra cost, increase structural efficiency, And essentially waste is eliminated through the construction process due to the lack of formwork. So how does mesh mold technology work? So this is actually from a member of the original research team. So the mesh molds are produced by a robot using the wire application method. So the first part of this process would be automated bending and welding process. And this kind of produces double curve meshes from steel rods up to 12 millimeters thick or thermoplastic polymer mesh. So it can either be produced from the steel rods or it can be produced from the thermoplastic polymer mesh. Two different ways. I've seen a couple different organizations or companies that have branded it that do it differently. So prefabrication takes place in the factory, but can also be completed on site. Due to the precision and dexterity of the robotic arm, the necessary complex mesh geometry can be formed. How does mesh mold technology work? Continued. So this would be number 2. They developed competitively priced and efficient formworkless concrete mixture and filling method. So not only are we mixing it, but we're filling it to provide a complete structure. The concrete is modified prior to processing using silica admixtures. So there's that company that I was telling you about that did the admixtures, and the qualities of the admixtures themselves, along with the concrete, include that it still has to be pumpable, yet solid, so that it will not flow out through the mesh, unlike traditional concrete. And instead of adding extra material, like fibers, the wave-like structure of the mesh stiffens the wall against buckling forces. Number 3, the mesh can be filled and finished with standard concrete processing and construction equipment, which makes it easily reproducible. Number 4, after filling is completed and the concrete is manually troweled with hand tools, the mesh structure remains inside the concrete and reinforces it structurally. So with this technology, as of right now, you do have to still have some sort of human interaction towards the end of the finishing process, just to make sure, everything is smoothed out, completed as it needs to be. The robots don't have the capability to do everything quite yet, but they are working on it. And these are what type of concrete is best used or is best for application of mesh mold technology. So lower yield stress concrete should be used for the filling, and a much higher yield stress material such as shotcrete should be applied to form the outside or cover layer. And it has to have self-compacting qualities. So these are just some advantages and disadvantages of using mesh mold technology in construction. So with the advantages here, we see that it's essentially a waste-free process, and it can build load-bearing concrete elements of any shape without formwork. And I'll get more into that a little bit later. But because of that, you have greater freedom of design and sustainability and increased efficiency on building sites. So these would be the disadvantages, which are robots have limited loading capacity. Prefabricated components are limited by transportation regulations, such as size and weight, and they must be able to sustain forces of transportation and assembly. So essentially, if you can't get it there, then you can't use it. Possible joining failure due to manual installation requirements. So even though you've prefabricated everything up until this point, if you get it there and then somebody doesn't really do what they're supposed to or messes it up, then, that's a reason for joining failure. And then robotic in situ challenges. So these are the challenges that, we're going to see if we're trying to do things completely on site. So due to the building site environments, that they're unstructured, that can cause different problems. And we see that the mesh mold technology works, and but it's still different than having it in a factory environment that is controlled. So future applications of mesh mold technology in construction. So the first thing I kind of wanted to touch on with this is that what the next generation of in situ applications would need to look like. And these were recommendations that were given by a highly accredited researcher that I found. And so I just kind of wanted to touch on that. So we are going to need a new type of robotic armor actuator than what we have now, because as of what's commercially available today, sufficiently sized platforms with full force torque control at joint level and access to low level control loops for implementing dynamically capable control methods aren't available right now. So here are some recommendations based on the current issues that they're having with the technology. So I'm not going to read all of these, but obviously we need to make sure that the robots are a little more agile and are able to perform specific tasks that are maneuvers that they don't currently have the capability of doing. The payload capacity, they need to make sure that they're capable of operating with a 60 kilogram payload. The system weight, they just needs to, make sure that they can basically correspond with the current maximum loads of a standard floor. And for the arms, we want to improve on their reach, because I guess right now they are not super able to reach very far. So these are some more recommendations continued. So safety, robust in construction site, and control. So the position control, I know, is a big deal. So this is actually just another example of an application of mesh mold technology. So from what I was able to find during my research, there are two types of mesh mold technology that I could find. And this is the branch technologies approach, which is, they call it cellular fabrication, and it's actually located in the United States. So this follows mesh mold technology, but it uses carbon fiber reinforced thermoplastic polymer. And after the process of the mesh is installed, the matrix is filled with spray foam insulation, then covered by concrete. So this actually makes it possible for us to construct interior walls, which we weren't able to do before the branch technology approach was developed. So this is just a picture of what the branch technology approach looks like. And as you can see here, it is are formed with the polymer based technique versus the steel. And so just to kind of leave you guys with something, I wanted to show this video, and this is the mesh mold application in the DFAB house. The DFAB house was a project that they actually did in Switzerland. So you can take a look, and I hope it gives you a great overview of mesh mold technology.
The DFAB house is actually the first time very different new building technologies come together in an inhabitable building. It's a very exciting milestone for architecture, for science, and a future digital building culture.
Nest is the place where innovation starts, where we push new topics forward, like in this case, digital fabrication, thanks to a collaboration between academia and industry.
I think it's key that we were able to bring together so many different people from different backgrounds, both in research and in the industry, to build this project. Regardless whether you're a researcher or a professional or a builder or an architect, we all leave this project with a changed perspective.
The technologies shown here in the DFAB house, they have multiple implications and advantages. The ecology is much better if we build with these new technologies. The economy changes. And lastly, what we can experience here, the architecture changes. There is a strong societal impact by these new technologies and by literally taking the research out of the lab into reality, into a built, inhabitable house. We actually provide something very important to society and to experience these changes and discuss it.
Hey guys, so here's the link to the DFAB house project if y'all want to take a more in-depth look at it. And here are all my references that I used to write this presentation. So yeah, that's all I have for you guys today, and I thoroughly enjoyed working with everyone in the class and getting to know you guys. It's been fun, so thanks y'all. I'll see you later.